So this video is on Unit 10, Lessons 8 and 9. And in Lesson 8, we are talking about adding and subtracting with fractions. So if you read the first two pieces of information up here, you must remember that fractions must have a common denominator in order to add or subtract. So let's review really quickly an example without variables in it. We're going to just go back to like 5th grade when you first learned to add or subtract with fractions. So let's take the fractions 3/4 plus 7/6. In order to add those together, the bottoms must be the same. So you need to figure out a common number that you can turn both of them into using multiplication. And to save yourself a step at the end of having to reduce your answer, you want to try to find the smallest number that you can turn them both into. So I noticed that I can turn 4 and 6 into 12. And number 2 down here says you can only change the denominators by multiplying the overall fraction by the number 1, which basically means whatever you do to the top or the bottom, you must do to the top. So whatever you do to the bottom and do the top. Okay, so on the bottom, to turn 4 into 12, I would multiply that by 3, but I must multiply the top by 3 as well. 3 over 3 is 1, so that's okay. That's a legal move in math. 6, to turn that into 12, we're going to multiply it by 2, but whatever I do to the bottom, I must do to the top. Now I have, if you multiply each side out, that's 9 over 12 plus 14 over 12. And now you can add straight across. The bottoms stay 12. Whatever the common denominator was, that's what the denominator will be of your answer. And you just add what's on the top. So 9 plus 14 is 23. Now that is an improper fraction, so you should probably reduce that to a mixed number. But for time's sake, we're just going to leave it. Now, if you cannot think of a smaller number, or you cannot think of what to turn the denominators into, let me show you what would happen if you're stuck. If you are stuck, you can always rely on multiplying the left side's fraction by the right denominator and then the right side by the left's denominator. So you could multiply this guy by 6 over 6 and this guy by 4 over 4. The problem is when you get to the end, you're going to have to reduce since you did not find the smallest number that you could turn them both into. So this would be 18 over 24 plus 28 over 24. So now if you add straight across, the bottom is 24 because that's your common denominator. This would be 46, and both of those are even, so you can definitely reduce them. If you divide them both by 2, you will get 23 over 12, which is what we got up in the beginning. So if you don't find the smallest common denominator, you are going to have to reduce. But the beauty about it is if you can't figure out what the common denominator should be, you can just multiply the one side by the other and vice versa. So let's do an example where we actually have some x's in our fractions. So if you look at the first example, this denominator is 4x, this denominator is 6x. If one of your denominators has an x in it, they both must have an x in it. If one of them has an x squared in it, they both must have an x squared in it, and so on. Well, luckily they both have an x, so I don't have to worry about that, but I do need to turn the 4 and the 6 into a common denominator. So I did choose the same numbers up there on purpose. So we're going to multiply this guy by 3 to turn it into 12. But when I do the top by 3, make sure you multiply the entire top by 3. Over on the right side, I'm going to multiply the right side by 2. But again, make sure you multiply the whole right top by 2. So on the top, I now have on the left 6x minus 15 all over 12x plus 8x plus 4 all over 12x. So now I know when I add them together, my bottom is going to be 12x in my answer. And then on the top, I'm going to combine my like terms using addition. So I can add 8x and 6x, so that's 14x. and then negative 15 plus 4 is negative 11. You cannot reduce this any further because you can't divide both terms by 12x, so just leave it. If 12 could be reduced with both of the terms on top, then you could simplify it, but you can't. Okay, so the next example, I am going to turn the 5 into 10, so by multiplying this side by 2, but the problem is that on the left side, I have an x in my denominator, on the right side I don't, which means I just have to multiply this right side by x, but whatever you do to the bottom, you must do to the top. And make sure you multiply everything by x on the top. Okay, so on this I'll start on the top. On the top over here, I'm going to have 8x minus 2. And on the bottom, 2 times 5x is 10x. Plus, on the top, on the right, I'm going to have x squared plus 5x. And on the bottom, I'll now have 10x. So I know I did it right because I ended up with the same number on the denominators. So now my denominator, my answer is the same as the other two. It's 10x. And when I combine my like terms up here, I'm going to put them in order of the largest exponent down to the smallest. So I'm going to put x squared first, and there's no other x squared. The x's, there are two x's that I can add together, 8x and 5x, that's 13x. And then there's nothing to combine with the negative 2, so he just stays negative 2. And that's your final answer. The next one, so this one looks kind of ugly because if you look at the two denominators, it might not be clear at first what the common denominator is going to be. So you need to get into the habit of factoring the denominators if possible. You need to look for 1am type of factoring, perfect square, GCF, or you might have to do split the middle. So in the first, on the left side, on the bottom, I can take a GCF out of 5, and I'm left with y minus 3. On the right side, that's a perfect square. That factors to y minus 3 times y plus 3. Well, now I can notice my common denominator basically has to have one of everything that's on the left and the right together. Well, they both already have a y minus 3. But this side is missing this side's y plus 3. So I'm going to multiply this side by y plus 3, but whatever I do to the bottom, I have to do to the top. And now this side has y minus 3 and y plus 3, but it's missing this guy's 5. So I have to actually multiply this guy by 5, but whatever I do to the bottom, I must do to the top. Now I have all three things are the same on both fractions denominators. So that while it does look ugly, that is the common denominator. So I know that my answer is the bottom is going to look like this. And it really doesn't matter what order you put them in because it's multiplication, but usually we do put the number out in front and then the parentheses that have the variables second and third. So on the top, so I got to multiply that out. So if I multiply this top by y plus 3, I get 4y plus 12. All over 5 times y plus 3, y minus 3. So that's my common denominator. Plus 5 times 5 is 25, all over 5 times y plus 3, y minus 3. So now I know my common denominator, and my denominator, my answer, is going to be 5 times y plus 3, y minus 3. And on the top, I'm going to add together any common terms that I can. I can add the 12 and the 25. The 4y has no other y to combine with, so he stays 4y. But 25 plus 12 is 37. And that's your final answer. All right, the last one. The trickiest part about the last one is that it's subtraction. Make sure when you are subtracting, I'm going to put parentheses around the second fraction. Make sure you subtract the entire top, because right now it's only a 6, but as soon as we get common denominators, there's going to be something else up here with the 6. So when I look at these denominators, it's kind of tricky to know what the common denominator is going to be until I factor. This guy on the left is a perfect square. It would be x plus 2, x minus 2. This guy is 1am. You're going to factor that. You need the factors of 20, negative 20, that give you 8. That's going to be x plus 10 and x minus 2. Now, let's look at the ones they actually have in common. They both have, whoops, I underlined the wrong one. They both have x minus 2, so that's already common. But this side has an x plus 10, which means this side needs to have an x plus 10. So I'm going to multiply this side by x plus 10, top and bottom. And now this side has the x plus 10, it has the x minus 2, it's missing the x plus 2. So I'm going to multiply this side by x plus 2, top and bottom. So now on the right side, I get x squared plus 10x all over my common denominator. It doesn't matter what order you put them in, x plus 10, x plus 2, x minus 2. And on the top, make sure you keep your parentheses because you want to make sure we subtract everything. But on the top, I get 6x plus 12 all over x plus 10, x plus 2, x minus 2. Now, when I subtract the first fraction minus the second fraction, make sure you're subtracting both of these. If you want, you could distribute the negative into the top so that you don't have to worry about the parentheses. But there's nothing, no other x squared to subtract off from this x squared. So x squared is part of my answer on the numerator. Then I have 10x minus 6x. Well, that's 4x, whoops, plus 4x. And then there's nothing here to subtract with the 12, but be careful because if there's nothing, that's really like a 0. 0 minus 12 is actually negative 12. So be careful that that positive 12, you don't forget to actually make it a negative 12. All over x plus 10 times x plus 2 times x minus 2. Now, you may think you're done, but you actually need to check because if the top can be factored, which this can be factored, you want to factor it because you might be able to cancel out some common factors where one is on the top and one is on the bottom. So if I factor this using 1am, 6 times 2 is 12. Well, one of them has to be negative, and then I can add that up to 4. So this factors to be x plus 6 times x minus 2 all over x plus 10, x plus 2, x minus 2. Well, you'll notice that the x minus 2's can cancel each other out because that's the same exact factor where one is on the top, one is on the bottom. So your final answer would be x plus 6 all over x plus 10 times x plus 2. You cannot cancel out any of these x's because they are attached to these numbers with plus signs. Remember, you can only cancel things out that are being multiplied together. So you'd have to be able to cancel out the entire x plus 6, and you can't. There's no other x plus 6. So that is it for lesson 8. On to lesson 9. Lesson 9 looks really ugly, but if you follow the steps I tell you, it's not too bad. Also, do not follow what this definition says. There is an easier, shorter way to do it, but I think that most of you will confuse it with the last lesson, so I'm going to teach you a different way. My way, write this down. You clean up the top, and when I say clean up, I mean turn it into one fraction. You're going to then clean up the bottom if necessary. Sometimes you don't have to clean up the bottom. There already is one fraction. And then you're going to copy, change, flip. So again, when I say clean up, I mean get one fraction on the top, one fraction on the bottom, and then copy, change, flip. So on the top, there is 2 fractions. I'm going to get common denominators between these 2 only so I can combine them into one fraction. So if I multiply the 1/2 by 5 over 5, I will get on the top, I'm going to do my scratch work over here, I would get 5 over 10 minus 1 over 10, which is 4 over 10. So this fraction now turns into 4 over 10 over, I don't have to clean up the bottom because there already is a single fraction, it's 2/5. Now I'm going to copy, change, flip. So I copy the top fraction, I change division to multiplication, and I flip the bottom fraction, and then you just multiply straight across, or you could reduce first. I might reduce first. So I'm going to actually reduce the 5 with the 10. 5 divided by 10 is 1/2. And then I'm going to reduce the 4 with the 2. That reduces to 2 over 1. Now I'm going to multiply straight across. 2 times 1 is 2. 2 times 1 is 2. 2 over 2 is 1. And that's your final answer, 1. Okay, the next one looks a little bit uglier because there is actually 2 fractions on top and 2 fractions on the bottom. So first, let's ignore the bottom, clean up the top. My common denominator is going to be 3x. So I have to multiply the left side, top and bottom, by x, the right side by 3. So I get on the top 2x over 3x plus 6 over 3x, which equals 2x plus 6 all over 3x. On the bottom, I have to get common denominators. Well, it happens to be the same thing. It's 3x again. So I'm going to multiply this guy by x, top and bottom, this one by 3. So I get 5x over 3x plus 15 over 3x, which I can then turn into a single fraction of 5x plus 15 all over 3x. Now I'm going to copy, change, flip, because I have a single fraction on the top, a single fraction on the bottom. So I copy the 2x plus 6 over 3x. I change the division to multiplication, and I flip the bottom fraction. Now when you flip it, you'll notice something nice actually happens with the 3 x's. You can cancel those out because they are common factors where one is on the top, one is on the bottom. They divide out to be 1. And then you might be thinking, well, there's got to be something else I can do, and there actually is. If you GCF each of these terms, or each of these binomials, on the top, if we pull out a 2, that's left with, you're left with x plus 3. On the bottom, if you pull out a 5, you're left with x plus 3. Well, now you have 2 factors. You have a 2 and an x plus 3, and then you have another 2 factors, 5 and x plus 3. Well, the x plus 3's can cancel out because they're exactly the same. So now I multiply straight across with anything that's left. Well, the only thing that's left on the top is a 2. The only thing that's left on the bottom is a 5. So that ugly fraction that we started off with simplified down to 2/5. All right, the last one. So we are going to focus just on the top. The common denominator is going to be x plus 2 times x minus 4. So I have to multiply this side by x minus 4, top and bottom, and this side by x plus 2, top and bottom. So on the top, I'm going to get 4x minus 16 plus 2x plus 4 all over, my common denominators are x plus 2 and x minus 4. I'm going to clean up the top by combining my like terms. 4x plus 2x is 6x. Negative 16 plus 4 is negative 12. All over x plus 2 times x minus 4. Now I have to clean up, well, actually there's only one fraction on the bottom, so I don't have to clean up the bottom. All I have to do now, I'll rewrite it, but I'm going to copy, change, flip now because I already have a single fraction. While it is long and ugly, it's still just a single fraction on the bottom. So I copied the top. I'm going to change to multiplication. I'm going to flip the bottom. So the x squared now is on the top. And on the bottom, you get the 12x minus 24. So you kind of did the hard part. Now you just have to simplify by factoring any numerator or denominator that you can and then canceling out common terms that are on the top versus the bottom. So I'm going to work right below this, but on the top here I can factor out a 6 and I will be left with an x minus 2. The bottom is already factored. It's x plus 2 times x minus 4. You can't factor that any further. Remember, you can only factor if there is a GCF or an x squared. The top here is a 1am. So I'm going to have x, and I got to think of a way to multiply to negative 8 and add to negative 2. Well, that would be negative 4, positive 2. And then the bottom is a GCF. I can factor out a 12. I'll be left with x minus 2. So now I'm going to go ahead and start canceling or reducing numbers. As long as one is on the top, one is on the bottom, I can cancel them out if they're exactly the same. So I see an x minus 2 on the top here with an x minus 2 on the bottom there. I see an x plus 2 on the bottom and an x plus 2 on the top. And then I notice a 6 and a 12 can be reduced to 1/2. So that's really a 1 and that's a 2. And that, oh wait, there's an 2x minus 4s. We have one on top, one on bottom. So actually, almost everything cancels out, except for on the top, I technically have this 1. And on the bottom, the only thing left is that 2. So that ugly, ugly, ugly fraction to start with reduced down to 1/2. Remember, to check if you reduced correctly, pick a number. Well, this one, if there's no x's, you can just type it in the calculator. But if there are x's, pick a number to plug in for x. Remember, don't pick 0 or 1. Pick 2, 3, 4. I like 3. So I would type this in my calculator exactly how it looks, but replace the x with a 3. Then type in your answer. Well, you better get 2/5. Otherwise, you know you simplified wrong. Same thing over here. Plug in 3, type it in exactly how it looks, and hopefully the calculator will tell you it's 1/2. So that is it for this video and lessons 8 and 9.